In this video, we'll cover some basic ideas about the rate or speed of chemical reactions, which is what chemical kinetics is. We should be able to explain why several variables such as concentration, temperature, surface area, and catalysts are able to affect rate of chemical reactions by the end of this video. I think we're already familiar with the idea that some chemical reactions are fast while others are slow. For example, the several reactions on the left occur pretty fast. These are single replacement, double replacement, and electrolysis reactions in that order. Notice that it's not fast-forwarded. The reactions on the right are fast-forwarded though. These reactions on the right are very, very slow. And the ones being shown here are crystallization reactions, which is what happens when a solution is saturated with a dissolved solute. The study of the speed of chemical reactions is a branch of chemistry called chemical kinetics. In order to discuss about the speed of chemical reactions, we first need to answer how does a chemical reaction happen in the first place. We have an example of a chemical reaction below, involving hydrogen gas molecule and an iodine gas molecule, reacting to form two hydroiodic acid molecules. You might already know this, but what must happen between the reactant molecules for them to turn into product? They have to collide with each other. Actually, there's just a little bit more to it. This brings us to an idea called collision theory. In order for a chemical reaction to actually happen, the reactants must, like we said, collide with each other. But they need to collide with enough energy. Just touching won't cause a reaction to happen. Lastly, they have to also collide in the correct orientation. Let's look at a few scenarios to illustrate this. The first scenario, our hydrogen gas molecule and iodine gas molecule collide with a lot of speed and energy. Also notice that the two molecules of HI can form based on the orientation that they collide in. Therefore, there is a reaction. Again, because the collision has correct orientation and sufficient energy. In the second scenario, our hydrogen gas molecule and iodine gas molecule collide with lots of speed and energy, but notice how the orientation is different. It wouldn't allow for two molecules of HI to form. This means that there's going to be no reaction because of incorrect orientation. Even though there's enough energy for this reaction, the incorrect position prevents this reaction from happening. In the last scenario, the hydrogen gas molecule and iodine gas molecule collide with very little energy. It's just not there. Even though the molecules are in the correct orientation during the collision, the lack of energy prevents the reaction from taking place. So, again, for a chemical reaction to happen, you must have a collision. The collision must be high in energy. And also, the collision must be in the correct orientation. Before watching this video, we should have already watched this other video that showed you the factors that affect the speed or rate of chemical reactions. If you haven't yet, then I encourage you to watch it. Just pause the video and type in the video link you see here. If you already saw this demonstration, then you should be aware that there are several factors that can speed up a chemical reaction. Things that you can actually change for a reaction are its concentration, its temperature, its surface area or shape, or by adding a catalyst if there is an available one for the reaction. We can now piece together our knowledge about factors that affect reaction speeds with the collision theory to actually explain why each factor causes reaction speeds to change. In this task, I want you to mentally arrange the four factors below to whichever part of the collision theory Venn diagram you think would explain why there's a change in speed. We have four factors here: increasing concentration of reactants, increasing temperature, increasing the surface area of reactants, and adding a catalyst. We have the components of the collision theory right underneath. There's frequency of collisions, colliding with enough energy, and colliding with the correct orientation. So basically, for each of the four factors above, mentally place it in one spot of the Venn diagram. You should pause this video and give it a try. But before you do that, I want to give you two definitions that will help you out. The first is temperature. Formally defined, temperature is a measurement of the average kinetic energy, or speed, of the particles being measured. Also, a catalyst is a substance that speeds up a chemical reaction without itself being consumed. It does so by holding reactants in a desirable orientation with other reactants. You can see the simple illustration of this right here. Make sure you take a look at this. Okay, so let's pause the video, and when you've arranged the four factors yourself, you can finish off this video by checking your understanding. The first factor is increasing concentration of reactants. By doing this, there's going to be more reactant molecules in the system. That means there will be more chance for collisions since it will be more crowded. Therefore, it goes here. Next, we have increasing temperature. If you have a higher temperature, then that means the particles have higher average kinetic energy, or speed, by definition. If things are moving around faster, then that means there will be more collisions, and the collisions are going to be higher in energy. Therefore, increasing temperature will fit here in the Venn diagram. Next, we have increasing surface area of reactants. Now, normally, if you have a reactant that is in a massive clump, then the particles that are in the center cannot react because there are no chance for them to collide with other reactant molecules. However, if you increase the surface area, this will expose those particles and make it possible for them to collide with other reactant molecules. That means increasing surface area will increase the frequency of collisions. Okay, for our last factor, adding a catalyst, if you just look at the definition of a catalyst again and peek at the diagram of how a catalyst works, you should easily explain that a catalyst will speed up a reaction by increasing the amount of collisions that have the correct orientation. One note about this though, you can also argue that a catalyst also makes it so that the collision has enough energy. So we can also place it right here if you wanted to. And there you have it. These are the parts of the collision theory that explain why these various factors increase the speed of chemical reactions. I have just one short question for you to do. After you're done with it, I'll give you some feedback.